Alright guys, so today we're going to be talking about how to represent very large and very small numbers using scientific notation. It's going to be one of the big benefits we get out of using SI notation, is it's really kind of a pain in the butt to write a number like 6,400,000,000, we'll just leave it as zeros after that. There's our billions, millions, thousands, hundreds. It's a huge number. It's kind of a pain in the butt, right? So we're going to use SI notation, and I know a lot of you have seen this maybe in chemistry before. Some of you were like, I love that, and some of you were like, I never quite got how to do that. So the key with SI notation is that you're just having only one number in front of the decimal place. Like right here, our decimal place starts all the way over there. And now we can shrink that simply by moving the decimal place. So we can just look and go 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to move that all the way over, counting the number of steps we go. So here's 1 step, 2 steps, 3, 4, 5, 6, 7, 8, and 9 spaces. We moved it until there's only one digit to the left of the decimal place. All right, and that's going to be our trick to going into SI notation when we have a really big number, is we move them left. So in this case, we turned our giant number into 6, and we put our decimal place. Then we're going to put our first digit after the decimal place. So 0.4, 6.4. And now we have to say, anytime we do this, times 10 to whatever number we moved the decimal places by. So 6.4 times 10 to the 9th, and we now shrunk that giant number down to this. There's actually what's nice is there's kind of also an easier way to write it even, is we use E notation a lot here at MHS. And so that's 6.4. Then the E replaces the times 10, so just 6.4 E9. That's going to be our replacement for doing large numbers in SI notation. I'm fine with either one of these. You can write a large number in SI notation, it's like 6.4 times 10 to the 9th, or whatever the number ends up being. Or you can use the E notation because it saves you even more writing, which I'm always a fan of. Now, if we go the other direction, and now we deal with a really, really small number, right? Let's say we're dealing with like 0.000000042, right? It's a tiny number, super tiny. And look at all those zeros. If I ask you to write that down on a document or do that anywhere, or we're using that number all the time on a project, that's going to start really adding up, and it just gets annoying. I mean, realistically, we're only saving so much time here, but we're saving the frustration of constantly writing long numbers. So the process is the same here. We're just going to move the decimal place until there's only one digit to the left of it. But now we're going right instead of left. So here we go. 1, 2, 3, 4, 5, 6, 7. All right, we moved it 7 times over. Now on the other side, when we went to the right, we went positive, right? So this is a positive 9 because we were on the right and we moved to the left. Here we're on the left, we're moving to the right, so we're going to use a negative number. This kind of makes sense. It's helping to represent that we have an extremely small number. We moved over 7 times, so we're going to take our 4.2. Then we're just going to do the same thing, times 10. Since we moved from the right to the left this time, it's going to be to the negative 7. All right, so 4.2 times 10 to the negative 7, or 4.2 E7. That's all there is to it, right? Oh, I almost forgot my negative right there. I'm hoping some of you were going like, wait, what? So 4.2 E negative 7, or 4.2 times 10 to the negative 7th is going to be how we do the very small numbers like that. Right? So just remember, really large number, you're moving to the left, and it's going to be a positive exponent. Really small number, you're moving to the right, and it's going to be a negative exponent. Either way, you're always moving the decimal place until there's only one digit to the left of it. So here we moved until there was 1 to the left of it to get 4.2. Here we moved until there was 1 to the left of it to get 6.4. All right, well, I hope that was useful to you. We're going to talk about it in class, of course, but if you're on the weekend being like, wait, I don't remember anything about what we talked about, take a look at the PowerPoint that's still available to you from the landing page for that week. And also, you can refer to this video. Thanks, guys.